Yeah, and today we are very, very honored to have Mike Freeman here from Observable to give us a tutorial on plotting using Observable for DataViz. He'll introduce himself some more when we get to this portion of the talk, but I'm going to take a few minutes really quick to orient you to what we're going to do today. I'm welcoming you right now. We're going to take a few minutes to do some polling on Slido, which will hopefully get a sense of who's all out here, what you're interested in, and how familiar you are with some tools used for DataViz. Then we're going to have about an hour of Mike taking the reins and giving us a demo. That's going to be interwoven with questions, so feel free to put your questions in the chat or raise your hand and we can talk. If we seem to be going down a wormhole, I'll try and bring us back so that we wrap up within an hour. Because Mike has to leave at 3:15 Eastern time. Not exactly sure what time it is for you all. But then we're going to take some time at the end, give you some announcements about the bigger part of this group, and then we're going to stick around and chat. So if anybody wants to stick around and meet up, that's the time to do it. We're really excited to meet you. All right, repeat tips. That'll be the third time if I do it. So I'm going to skip right through. Quick orientation to our group. We are CDI DataViz. We are hoping to create an open community for data visualization practitioners to gain exposure to a diversity of skills, tools, and perspectives. We're trying to act as a resource for data visualization guidelines and best practices, especially from the perspective of using it within a federal agency. And we hope to connect with others. We're all doing really fun stuff, and it's nice to know who people are and how they're working. So this is the place for it. All right, so now we want to hear a little bit about you. We are going to use this platform Slido. You can join on your phone if you open your camera app and scan this QR code, or you can just use it in your browser. Go to slido.com or sly.do, I think. The internet will take you there, and enter the code Observable. All right, let's go to the next one. It should integrate with the next slide. Okay, so our first question for you, I'm going to join with my phone, is do you use code to interact with data in your, especially in your work, but also outside of your work? Oh, yes, we can definitely send the link. I see somebody in the chat. I'll let it go for a minute while I'm finding the link. Sounds like most of you do use data. All right, so there's the link in the chat, and you'll see a blue bar when you go to the browser link saying joining as a participant, and enter Observable there. It'll take you right here. All right, sweet. So lots of people are using code out there. A little over 3/4, going down a little. And also these slides, I'm going to advance through them, but the polling will be open. So if you are on a page, you're still welcome to submit, even if I move away from it on the screen today, which I think I'm going to do right now. So let's go to the next one. Will it go? There we go. Okay, this is an open text question. We want to know what your favorite tool to interact with data is and why. You can submit multiple answers.
That's a tough one.
Ah, D3 right off the bat. Awesome. Okay. R, Python. MATLAB. I haven't seen MATLAB in a while. That's awesome.
Free and widely used. That's always good.
Yeah. Tableau, Excel, good old Excel. It will never die. Mike, are you noticing anything that is exciting to you? I know that you were interested in hearing what tools and software people had used. Do any of these stand out to you?
Yeah, these are great. Hi, everybody. I'm Mike, by the way. I guess I'll say more about myself later. But as the guest, I did write or co-write some of these questions. I'm just excited to see that there's a good variety in programming language, using code, not using code, using tools, and reasons for appreciating these different approaches for working with data.
Okay, you can still submit on this, but I'm going to advance on the slide. The next question is, what are your biggest challenges when you're working with data? So true.
I feel like data wrangling, the time spent is often underestimated before you can get to those juicy parts.
Yeah, I feel like Holly, you specifically know this with the demo that we're going to do today.
Yeah, I really struggle with the unknown unknowns. Like, it's easy to anticipate certain things, then you get into some problem where it's like, oh, this location is formatted as some horrible string that I need to join on some other horrible data set.
Totally. Whoever said, quote, clean data set is spot on.
I also really like here that there's a blend of what we might call design challenges and programming challenges. So figuring out how to visualize something versus maybe running into issues with formatting or sharing those visualizations, getting them out on the web.
Mm-hmm. Okay, I'm going to submit. I'm going to move forward on to the next slide. But again, you can continue to submit if you want to. Okay, and then this one we're really curious. A lot of you are in positions where your data is intentioned for helping decision making, and sometimes when you're working with data, it can feel really far away from that decision making. And so we're curious: do you believe your data analysis does inform decision making in the end? And if so, how does it plug in? Sort of. It's a good question.
It depends on
I think the quietness on this question, I think, is an interesting indicator of how far it can feel or how nuanced the answer actually can be, depending on the situation or the project that you're working on. So it's really interesting to see people's articulations of this.
Yeah, I'm curious. People can feel free to maybe mention something in the chat here or also in the poll. Reason why you believe your data visualization might not be informing decision making. Like, is there a communication gap? Is it some other sort of barrier to getting that to be used? Is it that just no one is listening to you in the first place?
Mm-hmm.
Explain complicated models. That's good.
It's interesting. Analysis helps initial problem and decision frame. Like, I think that question of where visualization data is used in a decision isn't just at the end, it could be at the beginning.
Yeah, I feel like in our work, sometimes I see things framed as like, it provides the basis to potentially be used in decision making, but like whether or not it is not like a mandatory or known thing, but we are kind of like delivering that information so it's there.
Totally. All right, I'm going to advance the slide because I'm really excited to dive into this demo. But again, this will be open. You can submit. You can also add stuff into the chat if you want to. Okay, so I'm going to hand this over. I am going to I think, Ben, who's going to talk a little bit about the connection that you and Mike have together, and then get right into it.
Great, thanks. So my name is Ben Letcher. I'm in the Eastern Ecological Science Center, and I'm really excited to introduce Mike from Observable. And I've been using Observable for a couple of years and got to know Mike a little bit through some of their meetups. But it turns out I actually knew him virtually through a couple of apps that he had on his website, which is, shameless plug, mfviz.com, and also through some of his the documents for his R classes at the University of Wisconsin. So it was kind of a happy coincidence to realize that he was the same person. And we are really happy to have him here today to teach us about a super powerful platform called Observable for DataViz and exploration. And he's going to be super brave and do some live coding and give us an overview and show us a lot of the things that Observable can do. So Mike, let's do it.
All right, let's do it. I'll start sharing my screen. So you all should be looking at what we call an observable notebook, which is just available at this URL. I'll go ahead and put that in the chat, manage my windows a little bit. So you should be able to go to that link. You will see me doing some updates, and whenever I have reached a certain checkpoint, I can go ahead and share those updates, and you'll be able to see them on that link. So you're also able to make your own copy of that information, and this will be available to you after the talk. Also, if you're already bored, you can just come here and you can just kind of play with this for a little bit, and that'll keep you going for a few minutes. Try and touch one of these dots. So thanks so much for having me. This is great. I'm really grateful that you're taking the time, that you took some time to answer questions, give us a little bit of framing for the conversation. I am here today to talk about how we do a lot of the work that you all seem to be doing about data wrangling and visualization on this platform called Observable. First, just a little bit about me. I started my professional career at the Institute for Health Metrics and Evaluation. They do a lot of descriptive global health research. I've done a lot of COVID modeling more recently. So like a lot of you, I have experience in sort of the sciences and the research area. I was there for 5 years, both as a research fellow and also as a visualization specialist. When I transitioned over to the information school at the University of Washington, I spent 6 years there teaching various courses as a teaching professor. They were all about how do you write code to work with data. Some of them were in R. I wrote a book on R. There's a lot of free information about R, so don't buy a book. But it was something that helped support my classes. And my last few years, I started using this tool called Observable. And it was free to use in my classes. And it solved a lot of challenges that I was having around how to get students to share information on the web. And when an opportunity arose that I could go and work at that company that was making the tool that I was using to teach, it seemed like an awesome way to keep making a bigger impact on the visualization and education world. I've only been at Observable since mid-April, so I'm fairly new there, but have really enjoyed getting to do different events like this where I share information about it. And I'm also working on building utilities to make data wrangling and data visualization easier to do for people that do it. So that is enough about me. Here is a little bit about Observable. You're looking at it right now. I think of it as a platform for writing code to work with data. It is reactive, so any code changes that you make in a notebook are going to propagate across that notebook. It is collaborative, so multiple people can collaborate in real time. As an example, here you can see this is just some markdown code that is powering the content that you see here. I can go ahead and edit it. And I've shared this notebook with Ben. Ben, if you're in this notebook, if you want to come into this same cell and make a change, we should be able to see Ben making edits here in this About Observable cell. So there's Ben. He's making some edits. And I'm also making some other edits over here. So we have this collaborative coding platform where we're both able to contribute to the code, which one of us can evaluate, and then we will both see the results of that code. We can tuck the code away if we want to focus more on the results. Maybe I can't tuck it away when Ben's inside of there. So I'm able to see that Ben is in there editing. And this is how we can create this content. Right now it's just text, but it can also be data wrangling and data visualizations. So something that I love about this is that it's transparent. It combines both the code and the output into the same document. So if you're curious what data wrangling work happened, you're going to be able to see that here in the notebook. And it's also free. It's free to work in public or private. If you want to create something that is called a team and have unlimited private workspaces across your whole team, you can do that. But if you want to work independently or if you want to work in public, then this is a tool that is free for you to use, which is really important to me. So what we're going to do today is we're actually going to work with a data set that Colleen had prepared, and we're going to try and answer some data-driven questions. So this data set is about water supply and consumption at the county level from 1985 to 2015, available in 5-year increments. And I played with it a little bit and surfaced this handful of questions. So we want to know where water consumption is highest, whether or not there have been different trends over time in a particular state, looking at the counties in that state. I want to see within a given state how much variation there is across the counties in that state and just focus on sort of the most recent year. And then we can look at where water is coming from each state, whether that's groundwater or surface water. And the way I want to walk through this is to introduce you to the way that you can write code to answer these questions, both with the data and visually. So please don't hesitate to pop some questions in the chat. We don't need to pick apart necessarily every line of code, but getting a sense of how we can move through these and leverage different tools to do this. Are there any questions before we get started?
So Mike, what language is the code?
So when you create a cell, it's primarily backed by JavaScript. And JavaScript allows you to move around HTML elements, but you also have what we call different cell modes where you could write directly in HTML or Markdown or in LaTeX if you want to, say, write out some formulas. So if you just click on the HTML button, you can write whatever HTML you want. And you can also switch between different cell modes. If we said that that was JavaScript, it wouldn't know what to do with it. But we're mostly going to be writing in JavaScript, which I promise isn't as painful as it sounds. All right, seeing no questions pop up in the chat, we're going to load in our data set and then start digging into it. So you'll notice this pane over here on the right. We've got this nice little clipboard icon to attach files. So if you have something like a CSV file, you can add it or attach it to a notebook so that you can use it for your analysis. Colleen was gracious enough to prepare this data for us today. And if we just go ahead and click that little button, it creates a cell for us. It actually did it down at the bottom, but we can reorder these cells. So I'll just drag it up here. And we can load in that CSV file. Now, off the bat, this isn't something that necessarily is easy to parse. You see that it's an array of objects. That might not make any sense if you haven't used JavaScript before. So what we'll do is we'll put this in a variable. And one other tweak we can make is to say that we should try and detect what type each column is, if it's a string, if it's categorical or continuous. And then we can reference this raw data cell in other cells. So if you wanted to see it in a more readable format, we have these additional utilities called inputs. And if we just look at a table of this data, we can see what rows and columns are available to us. So not surprisingly, we have states and counties. All of them are looking at public supply of data. We're going to focus on a couple of variables today. This first one, PS gallons person day, is the number of gallons per person per day that are consumed in that county, I believe. And Colleen, feel free to jump in and correct me if I'm wrong. And we also have interesting information about the supply that's coming from groundwater versus surface water, fresh water versus salinated water, or the population of that county. So we really have a lot of questions that we could ask about this data set. So if you wanted a quick summary of this, something that I was working on was this function called a summary table, where we could put in that raw data set and we could get a really quick snapshot of first the rows and columns. So here we can see that we've got these 3 categorical columns: water use, county name, and state name. And we have all these different continuous columns. For each one, we have some visual representation. Not surprisingly, we have 50 states present. And then we have these histograms of every continuous variable. It turns out they look kind of funny here, where the year is just every 5 years. This county unique identifier just seems to increase. And then we have these distributions that are really offset. So we have these huge outliers that are driving most of the distribution of the histograms into these low values here, but we can see the means. And we also get some helpful summary statistics. So for example, this variable of interest about consumption is missing 42% of the time. We can see that the mean of this is 126, but the maximum here is 211,000. So in one of these counties, in one of these years, the gallons per person per day was 211,000. So something was happening in that location that we would want to investigate. So we've got our high-level summary that lets us sort of reflect on what we've got in our data here. We can see that maybe there are particular years where we're missing this 41% of the data, and we get the mean and the median as well. We can see that the median is a lot lower than the mean for a lot of these. It means we might have a skewed distribution. Again, we have some outliers here. Now, for those of you that are coming from Python or from R, you're used to having some sort of packages or libraries that you can lean on for doing your data wrangling. And the one that is that I prefer in JavaScript is called Arquero, relatively new. So we can take our raw data and we can pass it into an Arquero table, and then we're going to have additional functionalities that you're going to be familiar with, like filtering your data, selecting particular columns, grouping your data, and performing different types of, or calculating different types of summary statistics. So I'm just going to create something called data, and I'm going to say aq.from the raw data. So it's given us this table and even tells us the rows and the columns. And also because we're going to work a lot with this PS gallons person day, I want to rename that. I don't want to type that out in front of you. You all don't want to watch me retype that over and over again. So this has this .rename functionality where I can say I want to take PS gallons person day, and maybe I'll just call that consump. There's this nice utility where Arquero just has this .view, very similar to inputs.table, where we can see a quick snapshot of the data. Here you can see that it's the same data as above. One other thing that might be helpful is if we want to combine our state and our county into one column. And what we could do is we could derive a new column, and we could give it the name location. And to define that, this is something that takes a little bit of getting used to in JavaScript. We're basically going to iterate through each row, which is by convention abbreviated just by the letter D. And we could say that we want d.county name, and then we want to have a comma and a space, and then we want to have d.state name. And if we just want to see what that looks like, we can see that we now have this location column. Question in the chat about the benefit of Arquero. It is conceptually similar to the grammar of data manipulation that you're maybe used to coming out of R or Python. So we have these verbs that map to the functions that we want to apply to them, like rename or derive or group. It's very performant. It was developed by the UW Data Lab at the University of Washington, which has put out a lot of great tools like Vega and Vega Lite. So it is really robust and well tested. It's extremely performant. It's built on top of a data storage system that I don't know a ton about understanding called Apache Arrow Tables. So it's going to be really fast. And having used it really mostly in the last couple of weeks, sort of testing out different data visualization approaches or data wrangling libraries, it's got a really nice API. It's easy to chain these different functions together and can generate some pretty readable code. All right, so we've got our data to work with. Let's go ahead and start asking some of these questions about it, which we'll answer both by sort of honing in on the right part of the data, and then also creating some visualizations.
Like it might be good to just mention how chaining relates to the the operator in R that lets you put functions together.
Oh yeah, so this is basically like your pipe operator, right?
Yeah.
Where we're saying, group by, pipe, summarize, pipe, something else. This gives you this I think it's a really lovely syntax where each function returns the object itself, and then it has a bunch of methods on it so that you can continue to apply those different functionalities.
What's the curly bracket? What does that do in those like rename and derive lines?
Yeah, so each one of these things is a function, right? So dot from is a function that takes in this case, your data set. And then here we have the expected argument to those functions is what's called an object, which is something with key value pairs. So it is just expecting you to have this data structure come into it, this thing called an object. So an object is something like name is Mike, and it just gives you some sort of way of accessing that information. This is a common thing if you have a lot of like named parameters. Like in this case, we want to create something with this name, and this is how we're going to create that thing. Any other questions? Great. So if we want to know where water consumption is the highest, I'm just going to take off this .view argument so that it's actually storing the data in this variable we've called data. Then we can say that the top consumers, we would want to take our data set. And the first thing we want to do is just look at 2015. So we can filter it down. And again, we're going to use one of these JavaScript arrow functions where we just say, let's look at each row. And we want the year of that row to be 2015. You'll notice that up above there are 21,000 rows. Here, there are just about 3,000. So we're just looking at 2015. One way that we can just look at the top ones is we can order our column. So there's this nice dot order by, and we are curious about this consumption variable. For now, we can just say dot view so we can see it. And you can see that this, unfortunately, is sorted in ascending order. It's starting with the null values and then the zeros and then the ones. So what we're going to want to do is sort it descendingly. So there are a couple of what we might think of as like helper functions, things to help you do things like rqueros.descend. And now we're looking at our top counties. So we can read them out. You can see that the top location is Polk County, Texas in 2015. And we could read through these, but we also might want to create a chart of this, right? So we can go ahead and just grab the top 10 from 0 to 10. So those are our top 10. And now we have something that we might want to make a chart of. So I'll comment out this dot view so that that is storing our data of interest. And then we'll start making a plot. Already loaded into every observable notebook are a handful of packages and functionalities. One of them is called Observable Plot. This is an open source plotting library that we just produced that is built on top of D3 by the same creator as D3. So it has that sort of stamp of approval. And it gives you a syntax that I think is a lot like ggplot for describing how you want to map from your data structure to different visual features, but at a higher level of abstraction than D3 works. So there are these functionalities like plot.bar x. If we want to draw bars horizontally, we can take that top consumer data, and then we'll again use an object to describe the relationships between our data and the visual features that we want to encode. So we could say along the x-axis that we want to show the consumption. We can say that along the y-axis we want the location, and then we can just plot it. Okay, it was a lot faster than D3. As someone that loved using D3, loves using D3 for a long time, that didn't take 45 minutes or 2 days. It took 10 seconds. But we do have to go in and further configure this chart, right? You couldn't show this to your target audience. But there are a lot of configurations that are available inside of .plot. So just to make a few of them, we could put some margin to the left, not quite enough. So there's some spacing. And we can do things like make it a nice color, like we can set the fill to light blue. It's looking a little bit nicer. What we really want to do is probably sort these by the location. So this is something that we are actively working on incorporating, but for now, we need to basically write out the order that we want them in. It's not terribly hard to get out of our data set that we have right here, top consumers. So just to show what that looks like in a different cell, we can say top consumers, and we can get the location column. Is it column or columns? Column. And we can get the data that is associated with that. And that gives us those columns in that order. So we just want to pass this directly into our plot. I'll just go ahead and get rid of that cell. And here we can say for our y-axis, again, using an object to describe what we want to assert and about what topic. Here we can say that the domain of that axis is just going to be those locations in that order. We can even do things like set the label to an empty string. So now we've got a pretty well formatted plot with not a ton of overhead, right? Not a ton of pain points. If you haven't written code before, I definitely can empathize with the number of curly braces and commas and weird syntax. But we have created what we hope is a readable structure for organizing this information of like, okay, this goes on the x-axis, this goes on the y-axis, and you could switch them and see what they look like, which might be bizarre, but we'll try it. Doesn't work at all, because I think we're drawing bars along the x-axis here. I'll pause there for a second, just because this is sort of our first writing of wrangling code paired with plot right below. What is the semantic difference between putting something in bar x and plot arguments? Oh, that's a wonderful question. So here we have mappings between the mark that you're going to draw, in this case, the bar, and that mark will have properties like x and y and fill. And then everything that you describe inside of .plot is going to describe additional characteristics about the entire system. So in this case, how large or small you draw the y-axis. There are other formatting things that you can do as well. This is either going to be illuminating or confusing, but there's a different way that you can structure your plot commands. And that is that you could just say plot.plot. And inside of that, you can say, well, what do you want to draw? You want to draw some marks. You can draw any collection of different marks that you want. So you wrap them in what's called an array. Here, we only have one mark that we want to draw, and then we can also put this other information inside of that same function. So up here, we have sort of the shorthand for taking a mark, a bar x mark, describing the visual features of those marks, and then calling plot and specifying other things about the plot. Down below, we're just starting by saying, let's draw a plot. Here are the different things that we want to draw, the different marks, bars, dots. What else can you draw? Rectangles, text. And then here are additional specifications about what you want it to look like. Other questions?
So if I was understanding that right, like doing the plot.plot might be a good approach if you had multiple layers on the same chart that you wanted to do that were different kinds of like shapes.
Exactly. So I'm gonna worry myself and go a little bit off script here. And let's say that we wanted to place a dot at the end of every one of these bars for some reason. If we just say plot.dot, oh, there it is. Take that fill light blue off. So if you wanted to show that dot at the end there, if we get really not creative, but off script. Let's say that we say plot.text, and this is where we want to put the text, and maybe the text that we want to put is the actual number consump. Hey, that's pretty good. We, of course, wouldn't want the dot there anymore. But here we're going ahead and we are writing the number at the tip of each one of those bars. And I'm sure there's some sort of other argument like dx is 10, if you want to shift it over. That's not bad. I'm sure there's also some sort of formatting argument that you could write there as well. So for those of you coming from D3, like the leap from, oh, I want to write some rectangles, so I want to draw some text. It's like, oh, well, I don't have another 2 hours. But here we do have this I think, a pretty comfortable level of abstraction for doing that.
Yeah, that's incredible. One last question. Do you have a link that you could drop either now or later to documentation for this, just so we can see what, like, you pulled out bar X, dot, text, just so we know what the options are?
So I just put a link to a whole collection about observable plot. A collection is just a series of different notebooks. And there are different notebooks that dive into each one of these different visual marks or additional information, like about how you can group your data or break it into what are called different facets. And I'll also go ahead and just click this republish button. That means now if you go to this URL where I've been working, you'll see all the updates that we've made thus far. Okay, let's keep going. Next question, we want to look at the counties within a state. How have the consumption trends changed, right? So we want to see some sort of time trend, and we also want to limit it down to a particular state. Now, one of the many benefits of Observable is that the cells are reactive, right? You change something in one cell, it updates in another. So what I'm going to do is, rather than just say something like state is Colorado, I want some sort of way for the user to choose which state that they're interested in. There are a few steps here. First, we're going to need to get a list of all of the states. So we can say, let's take our data, and we can deduplicate it based on the state name. So then we just have one row for each state. I was trying to think of a simpler way to do this. There's like a little bit of awkwardness of getting in and out of this Arquero library. But we can just get this back, not as a sort of fancy table, but just in the JavaScript format, which we would think of as an array of objects. So here we have each one of these, and we just want to get the state name. So we could just iterate through those and just get back the state name. So you could spend, the better part of an hour trying to like parse this line if you're new to JavaScript, but we're going through each one of these elements and just giving back the state name. So now we've got our 50 states. And if we want to make a cool dropdown, we can say that we're going to create a select menu from those states. So now we've got this visual element we can use. And what this view of argument does is it says that this thing called state is going to show the underlying value of the element that you created. So whenever somebody changes this dropdown, it changes the word state. As you might imagine, we're going to then tie that variable state into what data we want to put into our plot. So this is one of the things that I was most excited about when I first started using Observable, is rather than like write some code, refresh, write some code, refresh, I could create user interface components that would allow me to do that exploration a lot faster than if I were sort of bouncing back and forth between windows. So here's our state. If we want to just a nice reminder, we again can pass an argument to this function that says choose a state. And then we could say that our chart data that we're interested in is we can start with our data. And what we want to do is we want to filter it down. We want all the years, but we just want this selected state. It turns out this is a little bit tricky. That's okay. We're not afraid of that because our query is going to tell us d.state name. Our query is like, hey, I don't know what this thing's state is. Just go ahead and wrap everything with this aq.escape. Okay, that could be worse, right, than just putting everything inside of some parentheses. So now what we've got is some sort of way where we can select something from this drop-down menu. Whenever this changes, the value of our cell called state changes, and all of the cells are connected to each other. So this is watching for changes to this thing called state. So whenever this changes, it changes state. This cell also reevaluates, and you have this reactivity that can really push forward your data exploration. I feel like I'm selling. I'm not. You don't have to buy anything. I sometimes hear myself. I sound like I'm selling something, but I'm just genuinely excited as someone who has spent a lot of time working with data for what this affords me in terms of doing this. So
and Mike, just real quick, if you had to do that for a web page in Vue or React or something, how much time would that take?
Yeah, I mean, it would, if I had to just do these two cells, you know, I've been teaching web development for 6 years. Like, I would set aside an hour. Like, I would set aside the time to like create an environment and create a React app, and then create event listeners that are watching particular things. And those tools are great, right? React is a great tool and Vue is a great tool, but the thing that I really enjoy about using Observable is like I don't have to do any of the infrastructure. I don't have to worry about how all these pipes fit together and creating the whole, you know, system of creating them. Like it does it for you.
And the other thing you may have seen during some of the responses to the questions is frustration with where do I put my web app?
Right.
Boom. There it is.
Right. So this
is something you can share. You got to get permissions from USGS to share it, but I found that to be pretty easy.
Yeah, you send someone a link, right? And there isn't this back and forth of, hey, can you give me the data from this other place? You create a little menu and someone can do that.
So in the big picture world, if I can just editorialize for a second, I found observables to be super useful for that sort of in-between place between a static graph or a simple story map and a full-blown web page. There's this huge range in between of sort of explainers where you can make relatively quick web apps that can explain complicated data pretty quickly. And that's a big space. There's a lot of room in that space for the kinds of things we do.
Yeah, I mean, when I get a data set now, I load that CSV file into a notebook and I show it in a table and I put it in summary table. It's the first thing that I do, and I created the summary table function. Like I'm biased towards it, but it did those first 10 steps for me, and I didn't have to make the 10 different histograms on my own. I didn't have to, you know, set my working directory or create an R project or load it in. Like I love these different tools. I love using R, and I think that this scratches a particular itch where you see the code and the output together and can share it really quickly.
Yeah, and at the same time, this has kind of ruined R for me in a way because I want to be able to collaborate with somebody in real time, and I can't right now.
Yeah, and you know, Ben showed that he could quickly edit a cell, but having sat down for a couple hours with some of my coworkers, it's amazing how you can compose some of these statements simultaneously. And it's also really fun. Like it is an enjoyable activity.
And great for learning.
Yeah. Yeah. Well, let's make some charts. You know, I just want to hear Ben and I talk about all day about how cool Observable is. Okay, so we've got a time series for our selected county. A common way of showing trends over time is that we can show a line chart. We can take that chart data, pass it in. I gotta always remember to take this view off because we want to actually pass the data itself in. And we'll again just specify what we want to show, you know, how we want to map from our data features to our visual features. So along the X, we can show our year. Along the Y, we can show consumption. And then we're going to want to be able to distinguish between those lines, so we can use a different fill for each county name. And then we got to call .plot. Oh, I always use fill instead of stroke. Fill actually fills in the geometric object that you have. I actually like how these look. It's kind of like a fun, D3 broken made art piece. That's great. But what you probably want to see is stroke. The other thing that we can do is we can make sure that we're only looking at observations that aren't missing. You can see a lot of these don't actually go back to 1985. One way is that we could just filter the data set down again, and we could just say, make sure that d.consump exists, right? This will evaluate something like truthy if it isn't missing, and then it won't be filtered out. So now we can figure out what is happening in Polk County, Texas. This is but now we're missing, right? What we're missing is tooltips, something else that is in development in plot. So there are workarounds. This is, for those of you who've worked in Excel or Tableau, the power and the peril is that you can build your own workarounds, right? So I worked on a functionality called add tooltips. We can add some tooltips here, and we just need to tell it what the title is of each one of these marks. Is we can just go into each one and say d.location. And now, whenever I hover over something, the default is to give it a background, which we can also augment as passing another argument in here. And I think we can just say that we maybe just want the stroke to be black when we hover over it. So, okay, here is Liberty County, Texas. It looks like this county in Texas, Koch County, Texas, had a big spike and decline. I don't know why. And then Polk County, Texas has had this spike in between these two different time points. So something that you would want to look into if you are concerned about water usage, if you want to learn about those counties, as you're actually tied to this data set. So this operation where we can have this drop-down menu and say, oh, but there was also something in Utah that was happening, okay. Or you can just send this to another person that you work with, and they might come from Kentucky, and it turns out whoa, in 2005 in Kentucky, what on earth happened in Campbell County? Was this a leak? Is this a oil operation? Is this a big farm? This style of data exploration really lets someone that doesn't know how to write code, right? You can even hide all the code and just send them the notebook, allows other people to explore the data, right? You sort of write yourself out of a job or write yourself out of a task of this particular data set. So that's our second question. Yeah, we've got where the water is coming from. We've got these consumption trends. I was interested in seeing this one about how the water consumption varies within or across the counties within a state. We get a sense of that up here with our time trend. We're only seeing one state at a time. So we're now going to move away from maybe traditional graphics and can use the idea of creating different marks to generate our own representation of the data. So we again want 2015. Do we already have a data 2015? Maybe we'll just make that by taking data and filtering it down so that the year is 2015. And we want to see each county's consumption as a mark, and we want to have that organized by states. So we can just take our plot library and plot.plot. We're going to add a couple of different marks here. So I'm using this alternative syntax I talked about above, which I also lovingly refer to as upstairs or downstairs in the notebook. And here we can just draw some dots. We'll pass in our 2015 data. And what we want is to show along the x-axis is the consumption. And along our y-axis, we can show our state name. Unexpected token. Okay. Like many other things, this expects an object. And now we have each one of these points is a county for our state. We'll clean it up just a little bit at first. Let's put some margin left as 100. So we've got all of the counties' consumptions for each state. We can see that some of them have these larger outliers. A lot of them are, of course, clustered down at the bottom because of the variability in the data set. Something that we can do is change the scale type to be log scale so that we can, kind of see a little bit more of the nuances there, though whether or not people understand log scales is another question. And then I think what we're going to want to do is the same sort of sorting operation by the average consumption by state, right? So we want to have these all in a given order. There are ways to do that inside of the plot command, but I think it's also a good practice to see, can you do it in your data wrangling? Can you do it in the plot? So I'll just create state averages by taking our data in 2015. And this is where we can perform the same operation across different groups. If we just say we're going to group this by state name. And then we're going to want to calculate the average consumption. Our Query library calls this a roll-up. I think it's kind of fun. And what we want to roll up is, let's call this consump average. And the way that we get that is we go through all the different rows. We have to use this little helper function called op.mean of the consump column. If we want to see what that is, not a number. Oh no, that's not good. op.mean, group by state name, consump. Data 2015.view. We have something called consump. And we want to take the mean. Oh, that's not how we write that. Too many different libraries and options, and we just pass in, again, sort of like the consump property of that row. And we get the consumption average for each one of those states. And these are going to be a lot less noisy. It's not a population weighted average, but we also don't necessarily have all the counties and all the states. So this is a good, I think this is a good starting place. We can go ahead and order this. We remember that we want to do it in descending order by we called this the consump average. Dot order is not a function. This is a fairly helpful error message. I'm going to do an order by. So now we have them in the order that we want, and we just want to take that and use it to both inform our chart below and give us some additional marks. So jump down to our code here. We already have our dot marks. I just want to draw a vertical line at for each one of these states. So what we can do is draw a tick X. I always forget if it's tick X or ticks Y. We can pass in that state average and say that we want along the X-axis, we called it average, we called it consump average. Along the Y, it was state name. And let's just give these a fill of red, a stroke of red. I don't know why I always mix those up. We can even make those a little wider with a stroke width of 2 or 3. So now we can see the average for each state across the counties. And we'll use the same approach for sorting them as we had above, where for our Y scale, we can say that we want the domain to be our state averages. And we have to do this little trick again, where we want the state name column and dot data. Does that work for us? Columns. I ran into a little bit of an issue with this. I don't have a good explanation. This is something I need to learn a little bit more about Arquero. But when you order something, it shows you it's sorted, but it doesn't necessarily sort it internally in the data. And this .reify just sort of creates a new representation of your data having been sorted. I don't have a great explanation as to when you need to use it and when you don't. So feel free to follow up with me about that. But now we've got what I would consider a fairly complex graphic that you might show in front of a more scientific audience, where you have the log consumption of each county in each state. You're also displaying what the average is across the counties in that state in the most recent year that the data is available. questions, comments, or concerns? Is anybody concerned about this?
I have another question. I was just wondering if there's an easy way to then like embed this chart in another website.
Yeah. Yes, and so what can we do? If we click on these three dots here, it looks like embed is not yet enabled in our newest version of our software. But you could, for example, download a PNG file, which should, there we go. There's our PNG file, and then you've got your chart waiting for you right there. The alternative, I'm going to briefly, I'll republish this because I want to show you that there's a way to do this. If we switch back to our classic version of our software, mostly looks the same, couple of differences. I really like this mini map where you can jump down to different things. Here, the embedding, oh, it also doesn't work. Oh no. Oh, we have to name this cell to embed. Great. Let's call this, tree plot maybe. We just have to give it a name. And maybe I needed to do that in the new software as well. If we click embed, you can copy a URL only, and then there should be, I need to republish this. Your notebook needs to republish. Okay. So we can republish this, and then this this website should hold that tree plot. Maybe it'll take a second. Or maybe it doesn't like doing that publishing before I had republished this website. Let's take two. Embed, tree plot, copy URL only. Oh, there it is. So you could literally just send someone this, this website. There are also other ways of embedding this in a web application that I won't get into right now, but exist. So if you wanted it in your React application, there are ways to download. There are actually ways to download multiple cells. Like if we wanted to take, we got to give this a name, right? Line chart. And this has a name that's called state. I think we should be able to take these two things and put them in a website together. So if we take view of state and line chart, we can either copy it as an iframe, right? So you could put it directly in your website, or if we copy that URL, we should get a website where this works. Even the tooltips.
That's pretty awesome.
It's awesome, right? If the observable notebook is a little too cluttered or messy or whatever, like the fact that you can just grab those two different cells and throw them on their own website, and this is just a website that anyone could go to because it's published. So that's.
And so then if you updated the notebook and changed the code on those little bit, that's going to then like have downstream changes as well. If you were embedding it somewhere else.
We should make sure about that. So. You're, of course, as frustrated as I am that these years have commas in them because it's trying to do some smart formatting. But you might want to say, let's take the x-axis and set the tick format. Just don't do anything. That's a sort of a lazy way to do that, but it worked. We republished it. We come over here, and so much more relaxing. No commas in our ears.
All right, this might be a game changer in some of the stuff that we're doing.
Yeah, it's cool, right?
It's really cool.
I think like the ability to make this website with these two pieces together, I mean, it's a simple thing, but it's not if you don't know how to write the code. And I think Observable gives you a nice abstraction, right? Like sort of an easier place to do that code writing so that you can create these simpler tools.
Yeah, that's
all right.
Awesome.
So just to make sure, I'm going to switch back to I'm going to switch back to the most recent version of the software just because I've been hanging out there. Maybe I'll pause. We've got 15 minutes left. I have one other chart or maybe two charts associated with this question that I want to answer, but I'm also open to answering a different question about the data, answering some other questions that people have, really taking this time and making it valuable for the folks here on the call.
I guess I'm also curious if anybody's out there that has used Observable in something that they've done. I'd be curious to know about that too.
All right. Seeing no burning questions,
I have one.
forward. Yeah.
I'm wondering, outside of like the traditional like lines, points, etc., like, one of the benefits of D3 is like you can do like a lot of non-traditional chart types. So I was wondering what kind of support there's for that type of visualization through Observable.
Great question. So you can do D3 and Observable. You can do all the D3 is even loaded here, ready for you to D3ify anything that you want to do. So that support is there and ready to go. In terms of extending plot, I think you'll come across some limitations, but most things you can express in terms of where you want to draw dots, where you want to draw ticks, where you want to draw bars, where you want to draw rectangles. I've seen people make tree maps with plot. But yeah, I think almost all of the D3 documentation and examples all now live on Observable. So you can see all of those there, and you can see how people have chosen to use it. If we had 3 more hours, I could recreate this plot using D3, but we only have 10 more minutes.
I have a question also. So one of the things that I've seen, some of the work that we've tried to do has taken D3 and then tried to animate it with other libraries like GSAP. What's the integration like with other libraries that aren't built in like that?
Good question. So you call it, I don't know that library, it's called GSAP, G-S-A-P?
GreenSock, something.
GreenSock. Is that a JavaScript library or
Yeah.
it's like okay. Is a mixed popular WebGL. Okay, so GreenSock NPM presumably is on NPM as GSAP. So if you want to bring something into Observable, I've tucked a couple things down here in what is commonly referred to as the appendix. You can require different libraries. And if they're on NPM, it looks like it just went and found it in the easiest way possible. And now we've got back and bounce and anything else you want to do. It's not a function. It's just an object dot ease in. I don't know how this works, but it looks like we got GSAP. We just had to say require.
Wow, that's awesome.
Yeah, and there's like a module require debugger observable. So it doesn't always come right off of NPM, but there are a whole bunch of different ways that you can try and require something. So if you said GSAP, it should, and it might take a minute to go and actually check all of these different places, give you a couple of different approaches that you could use for loading that library. Yeah, so you can require it, you can import it, you can require it from bundle, you can require it from wherever that place is. So there are all these different ways that you can do that. The cool thing is that you can also import things from other notebooks. So add tooltips that will enable those tooltips is actually something that I wrote over here in this notebook. Right? So this notebook explains how you can add tooltips to any plot and gives you this functionality called add tooltips. And then you can use it in any one of your different notebooks, right? And so we could take anything that we've done in this notebook and import it into another notebook, right? Whether that's some of the analysis, getting some data, getting a chart, like even this this fun thing up here. I didn't do this. I just stole this from somebody else. So all the way down here, you can see that we imported that chart and also the colors that were used from this other notebook. So it just went ahead and brought that in. And then I just kind of put it where I wanted it. Other questions? Other comments?
It'd be great to see the map, Mike, I think.
Oh yeah, I wanted to make a map. So I had found someone else made a really nice notebook for making maps in sort of a reusable way. And because you can fork anything from anyone's public notebook, I just had gone there. You just click here and you click fork so that you can create your own copy on your own account, make your own edits. So I had made a fork of this notebook so that we could use state names instead of FIPS codes for US states and made things just a little bit easier. So I just wrote a function over here. You can see that it is based on this other person's function where he made sort of a reusable mapping tool to make cool maps like these. So if we wanted to do that with this data, I had sort of only prepared it at the state level. We do have our state averages, right? So that's something by state. So we've got a state name and consumption average. So if we wanted to use that, maybe we'll just call something map data is those state averages. I'm just going to rename that second column, consump average to value. So now we've got state name and value. And there was a function called draw state map that I brought in, passing in that map data. We need to just get the objects out. So there we have an interactive choropleth map where we can interact with it in whatever way. This is a good example of how much do you trade for customizability versus ease of use, where this is an extremely restrained function called draw state map that takes in state name and value in an array of objects. It'll create that tooltip for you. This was one way that I took this other code and it allowed you to specify the color scale and the tooltip contents and the administrative level of the data that you're working with. But those are all things that I would rather just forego in exchange for the ease of use, right? Where it would automatically just display the state name and it picked one color scale. So you can create these functions and then you can just use them in whatever notebook you happen to be in. So if you draw one map in a way that matches the styles that you like with the format that you like, then you can bring it in and just say, boom, here's the data. Just put it right in.
That's awesome. But when you do that, you do it on a fork of it. You're not importing it necessarily from the original source such that if they change it one day, then your function would change it. You do it on a fork.
Exactly. So the reason I would have imported it directly, but I wanted to make some changes. So I couldn't make changes to that person's notebook. I just wanted to make those little tweaks. So I instead just made a copy of theirs, made those little tweaks, and then brought it in from my own notebook. But you can see, the Arquero library is coming from the UW Arquero actually just has this up in a notebook. This is coming from, the D3 little chart there. I'm just bringing these in from those original users, but you want to make some changes, fork it, and then bring it from your own. Awesome. Well, maybe to zoom back out, right? We started with an empty notebook, right? We started with a little bit about me and just a couple of questions. We loaded this data in from a file that we'd uploaded into the notebook. Had a couple of different ways of getting a high-level overview, either viewing the raw data or summary statistics about that data. And then we started using this library called Arquero to do the data manipulation to answer our questions about water consumption in different ways. So we would prepare the data, and then we would pass it into these different charting functions driven by this plot library, which is open source and very, very new.
So Mike, JavaScript is hard, and for somebody coming from Python or R, how would you recommend they get started if this kind of thing is interesting to them?
That's a good question. I would try and recreate something that you've done in R or Python and just see, like, find your equivalents. So I think for data wrangling, that equivalent will probably be Arquero. I think for plotting, that equivalent will probably be plot. And then you are going to have to find those sort of painful pieces where you, I don't know, did some string formatting and regular expressions. Like, you'll have to look up the JavaScript equivalent of that sort of in piecemeal. But I would try and do a project kind of like this, right? Some sort of project-driven learning where you try and take a data set and wrangle and visualize it. Yeah.
Yeah, I know if Observable had been around when I started learning JavaScript, I would have learned it a lot faster. It would have saved quite a bit of time.
Yeah.
Partially because of the packages, and partially because you can see immediately what's happening.
Yeah, I mean, don't get me wrong, it's quirky and people can laugh at the oddities of JavaScript, but it's it's the language of the web, and people look at things on the internet. So this is where we have decided to live as a visualization company. Well, I'll put my email here in the chat. And if you're on, social media, Twitter, and one more time, here is the link to the notebook. And feel free to reach out if you have questions about, you and your team getting started using Observable, trying to figure out whether or not your projects can fit inside of this structure. And yeah, I just really appreciate that y'all took your time to come and learn a little bit about this tool that might help out in your analysis.
Thank you so much, Mike. I'm game changer is true for me, so I hope it's true for other people.
Yeah, I totally agree. I have really, really enjoyed watching you do this. I feel like it's definitely going to change some workflow. I want to invite everybody to unmute yourself for a second, and we'll have a taste of the real world and a cacophony of applause, please, for Mike coming in. This was awesome.
Thanks, folks.
That's awesome. All right, well, we're going to stick around for another 15 minutes or so. Mike, if you need to peel off, more than welcome to. Thank you so much for coming. And stick around for some announcements and chit-chat.
Awesome. I sadly have to go. I'd love to chit-chat. I do wish this were in person and we could, go out to dinner and all hang out at the next place, but this is the world we live in. And thanks again so much for having me. Got to run, but really appreciate it. And don't hesitate to reach out.
Thanks, Mike.
Thank you. Bye-bye.
Awesome.
Right. Well, now we're going to move on to some announcements. So if you don't know, we have a Microsoft team, and we highly encourage that you join it. It's a great space to collaborate. If you have questions, feel free to post on there. We have a couple different channels, and especially check out the meet and greet channel, because we would really love to get to know everyone who's a part of the group. And, it'd be a great networking opportunity as well. So I highly encourage you to go check it out after this meeting. Post a brief introduction about yourself. If you want to include, a favorite visualization, or if you want to create one, you're more than welcome to. But I understand we all have time constraints. So even if you're just introducing yourself, we'd love to meet you. And as always, we have our Confluence, and that will provide instructions if you are outside of DOI and you want to join the team. All right. Well, now I'm going to hand it over to Colleen. Thanks.
Yep. So after this, when it's ready, we'll have the webinar recording up on our page. And the next meetup that we have coming up, scheduled on the schedule right now, is in September with Cedric Scherer, and he's going to talk about lots of tips and tricks for working in ggplot to make really beautiful plots. So that's something to look forward to. The invite will be coming out for that later in the year. And we're also always open to any suggestions that you might have for webinar speakers or topics that you want to learn more about. We're here to help everybody and build this community around data visualization. So just let us know how we can do that. And now we're just going to hang around for a little bit longer. If anybody wants to stay around and chat, the coordinators will be here, and feel free to join us.
Sweet. And for anybody logging off, great to see you virtually, and thanks for coming.